Does that make sense to people? Okay, but so far we've been talking about pretty simple reactions. Let's go to ones where the outlook isn't as simple, or we have to mess with the experimental conditions to be able to study the reaction. One that you guys have already seen a lot before is pseudo first order reactions. Or at least you utilize this one. I hate the word pseudo because I can't ever figure out how to spell it. Okay, so we've already seen how complicated just tossing one more compound in our rate law, how much more difficult it makes the derivation of finding the integrated rate law or proving that that rate law is true. We want to simplify something. So let's say we consider the following reaction. We're going to say this reaction is an elementary reaction. We're going to describe those more in a little bit when we talk about mechanisms. But an elementary reaction is a basic reaction that you can actually derive the rate law expression from. The rate law is due to it being an elementary reaction. Ugh, you mean we're going to have to go through that full derivation that we were forced to go through a little bit ago to find this thing? Experimentally, is there anything you could do to make this simpler? What would you do? Yeah, leave one constant, and what would you do with its concentration? Yep, bump it up, make it really high. If we set up our experiment, and which one would you pick? Yeah. 2 reasons you'd pick OH. Give me a good reason why. Yep, less expensive. You don't want to say cheaper. What's another reason? What do you know about determining the concentration of hydroxide? Yeah, you could use the pH, which would be easy to tell you immediately how much is in there. But let's say I pull 1 molar off the shelf. How confident are you about that? You shouldn't be. Hydroxide sucks. You breathe on it and you change the concentration. So, however, though, if you make a really high concentration, it won't change too much. So if you set up our experiment where we have our hydroxide ion concentration much greater than our bromomethane concentration, what can we say about the hydroxide ion concentration? In comparison to at some other time, in comparison to the initial? Yeah, they're approximately the same. Okay, so that's going to modify our rate expression. How would our rate law change? So really, what's changing in here? Is K changing? No. Is this changing? Is that guy changing? Yes. So what could we do with the stuff that isn't changing? Yeah. We're just going to call that a new constant. And what's K prime equal to? Yep, K times the hydroxide ion concentration. And you guys have used that a lot before. A lot of times that's what people do to study individual orders. Like they want to make sure, hey, this is either first order, second order, third order, and so on. And they can do it that way. We have talked about the dangers of doing that. Any questions about that one?